real numbers are a category of complex numbers. The other category being imaginary, which is what we're talking about today. Are you kidding me? Never fails, guys, every day. All right, so first let's talk about what imaginary. Why are you not connecting? I definitely typed that in correctly. Oh, he froze it. Okay. So let's talk about what actually is an imaginary number. So, what an imaginary number does is that, as of right now, what you learned, if you took a square root of a negative number, so for example, let's say I asked you to put in your calculator the square root of -4. So in your calculator, take the square root of -4. What happens when you take the square root of -4? It gives you an error message and it says non-real. That's why it gives you an error message, because your calculator cannot calculate the square root of a -4 because it will not give you a real number. That's because negative radicals don't fall under the real number system. They fall under the imaginary number system, which your calculator can't calculate. All right. So if you think about it, that also makes sense. If you square a real number, all right, so if I didn't ask you to put that in your calculator, what would you have thought the square root of -4 would be? Maybe -2. Well, let's work backwards. What's -2 squared? If you put -2 squared in your calculator, exactly as I wrote, parentheses around the -2, what would it give you? +4. And we also know that 2 squared is equal to 4. So those are the only values that we can use that would give us anywhere in the realm of 4. So is there any possible way we can get a negative? Well, but that doesn't count, because the way your calculator reads it is 2 squared times -1. All right, but if we wanted to do a direct square root of -4, there is no number that we can actually get that would give us -4. There's no number squared that would give us right off the bat -4 without multiplying a -1 to it. So this also comes into play. This also comes into play when we're looking at the x-intercepts or zeros of a parabola. Because remember, what's another name for x-intercepts of a graph? Zeros. What else? Not domain. Solutions. All right. Solutions is the one I'm looking for specifically. All right. This whole unit's about solving quadratics. So x-intercepts typically give us the solutions. All right. So let's look at exercise 1. So they gave us the graph of y equals x squared. Now this is review from last unit. Y equals x squared is considered what? Who remembers the special name that describes y equals x squared in terms of quadratics? What is that called? It starts with a P.
Parabola.
Nope. Every quadratic's a parabola, but y equals x squared is a very special quadratic. It's known as the what function of quadratics. Starts with a P, ends with a T. Parent. It's known as the parent function of a quadratic. Does anyone remember what that means? Who remembers what parent function means? Think about parent-child relationship. We're calling x squared the parent. What does that mean about any other quadratic? It's based off of it. Good. So it comes from x squared. So x squared is the original. It's where all quadratics stem from. All right. So using that, we can find x squared plus 1. So let's think about this logically. With x squared plus 1, all right, it's just a transformed version of x squared. So think about this logically. If the y-intercept at this point is 0, 0, what's the y-intercept of x squared plus 1? 0, 1. How do you know? It's the c value. So this is my y-intercept, 0, 1. So it'll be right here. So what happened to go from the green point to the red point? What do we do? If we went from green to red, what do we do? Did we shift? Did we dilate? Did we reflect? What did we do? Come on, guys. Let's review from unit 1. You shift what? Up 1. Good. So we shift the whole parent function up 1. So if we did that, that means this, it would look like this. So 1, 2, negative 1, 2, 2, 5, negative 2, 5. That'd actually be more exact right here. So 2, 5, negative 2, 5, and then 3, 10, negative 3, 10. So this would be our new graph. So this graph is x squared plus 1. So the red graph is x squared plus 1. What does that say about the x-intercepts? Do we have x-intercepts now for the red graph? Does the red graph at any point cross the x-axis? No. So we don't have. So there are none or no x-intercepts now. Now, here's my question. From Math 1, if you found that there were no x-intercepts, what did you typically say about solutions if you were solving? What would that say? So, in Math 1, you were told, depending on how many times it crosses the x-axis, that determines what your solutions are. So if it crossed twice, you would say whatever the 2 x-intercepts were. If it crossed one time, you would say whatever the 1 x-intercept was. But what would you always have to say if it didn't cross the x-axis at all? No. No. No solution. Specifically, you were taught to say no real solution. Emphasis on real. So if you had no x-intercepts, it was no real solution. That's what you were taught to say. All right? But algebraically, let's figure this out. So if we set x squared plus 1 equal to 0, if I want to solve for x, what's my first step?
Subtract the 1.
Subtract the 1. So I got x squared is equal to negative 1. Then what do I do? Someone else. How do I get the x by itself? Get rid of the square. We've been doing it for like the past 3 days. How do you get rid of a square? You do what? It's literally what we've been doing the past 2 days, guys. We've been focusing on what? What did we learn about yesterday? What's literally been the lessons on for the past 2 days? Oh my God. Guys, what did we learn yesterday? What did you do your warm up on today? Zach. Radical form. So, in other words, radical, or what's the other name for radical? No. What's the other name for radical? Oh my God. What's the other name for a radical? No. Starts with an S, guys. Square what? Root. Oh my Lord. So to undo a square, you take a what? There you go. Good Lord, guys. Why do you think we were dealing with square roots? That's how you undo a square. So that cancels out. So currently speaking, x is equal to the square root of -1. Now, based off of if we put that in your calculator, what's it going to say? If you put the square root of -1 in your calculator, what's it going to say? Not real. So for right now, as it stands, x is equal to the square root of -1. This right here is where imaginary numbers stem from. So this is where imaginary numbers come from. So, like I just said, since we cannot solve this equation using real numbers, we have to introduce the new number. This number is called I. And all I stands for is an imaginary number. Yes, there is a number based off of a letter. But if you just know I, mathematicians, we do not complicate our naming skills. Imaginary starts with an I, so we call an imaginary number I. All right. All this does is that this allows us to find a square root of a negative real number. And it's based off of this definition below. So I is equal to the square root of -1. So if we look back at this previous problem, the square root of -1, if we simplify that further, x would equal to plus or minus I. All right. Because remember what I said yesterday, if you take the square root of a number and you're solving, you have to remember to put the plus or minus version of it. Just like how square root of 4 would be plus or minus 2, because 2 squared is 4, -2 squared is 4. So on the flip side, that means that I squared is equal to -1. So writing things out in terms of I is really easy. Okay. So here's how I remember I's. So basically, if there's a negative under the radical, the very first thing that you want to do is get that negative out from under the radical. And the way you do that is you take an I out. So I'm going to rewrite this one as I square root of 9. Now that the I is on the outside, we can take the square root of 9 like normal. Well, what's the square root of 9? 3. So is it just 3 or what do we have to put in front of it? Nope. It's 3, but something has to go in front of it. What sign has to go in front of it? Is it just positive 3? Plus or minus? This would be plus or minus 3 I. Because the imaginary number doesn't go away. All right. So this would be plus or minus 3I. Now, typically that's how you would answer if you were solving, but since it looks like they're getting a negative version over here, we're just going to also just say 3i. I would accept either one of those right now. So as of right now, if you put the plus or minus in front of it, that's fine. If you put 3i, that's fine. So the way I remember this is if the radical's being negative, that means you want to fight and you're going to take its I out. All right. So that's how you remember to deal with a negative radical. If the radical is being negative, or if the number under the radical is being negative, you want to fight it, so you're going to take its I out. It's morbid, but it's a way to remember it. So this one, it's a little hard to see, but there is a negative in front of it. So that negative is going to stay in front of it, but the negative under the radical, what are we going to do first? Turn it into I. So I'm going to take the I out. So now I got negative I times the square root of 100. So as soon as you take the I out, it becomes positive underneath. So what's the square root of 100? 10. So this would be negative 10i. So guys, typically you write the I on the right side of a number. All right, just like you would write a variable on the right side of a number. Now, if you wrote it on the left, I wouldn't count you off for it. Just know that typically it's written like you would an expression with x. All right. Now, it also comes into play when we simplify radicals. So simplifying radicals will be exactly the same. It's just our first step would be what before we simplify the radical? So before we simplify that radical, even if it's not a perfect square, we got to do what first? It's negative, so I got to take the I out. So I have I square root 32. Another way you can look at this is I could rewrite this radical as the square root of negative 1 times the square root of 32, which, based off of the definition that we just received, what's the square root of negative 1? It's literally on your paper. What's the square root of negative 1? Not I squared, but just I. The square root of negative 1's I. That's where I got that from. That's another way you can remember it. Now, since the i's gone, we can simplify 32 like we know how to do it already. So, what is a perfect square that can be divided into 32? Or what's the largest perfect square that can be divided into 32? 16. 16 times what? 2. So I can rewrite this as I times 16 times 2. So this would be I times the square root of 16 times the square root of 2. What's the square root of 16? 4. So this would be 4i square root 2. Try letter D on your own. Be warned, there is a negative in front of it, so your final answer will be a negative, even though there's an imaginary number in it. So my recommendation, start by taking the I out first, then simplify like normal. So guys, just remember, once you take the negative, once you take the I out, the negative under the radical is gone. It doesn't exist anymore. So negative 8. Got the 2 part right. So where's that? So what number is divisible? All right. I think most of y'all are pretty much done. So let's talk. So, what is my first step? Micah. So, what's my first step? So, with letter D, before I even start simplifying, I need to do what first to get rid of this negative underneath? We got to take the you got to take your, what am I pointing at? I out. So you got to take your I out. So since it's negatives on the outside, it's still negative. So I have negative I, and the 18 underneath becomes positive. Now we can simplify the square root of 18. So what's your first step, Owen? So factors of 18 were one's a perfect square.
So one factor of 18 is 9.
9, and what times 9 gives you 18?
And 2.
Good. So I'm going to rewrite this as negative I square root of 9 times 2. What do I do next, Riley M? Good. What do I do next? Luke. Which is 3. So I have negative 3I square root 2. Which, walking around the room, most of you guys got that. The only thing that I saw is that you just forgot to put that negative at the bottom. And again, the only reason we did that is because it was originally negative on the outside. So we just had to keep it. So just know, negative on the outside just stays negative like normal. Negative on the inside, take an I out. So now, Let's try solving these and putting their solutions in simplest radical form. But they're going to be imaginary, so we're going to get some i's in here. So we want to get the x squared by itself before we can take a square root. So let's solve this like a two-step equation. So what's my first step to get the x squared by itself? So if you're just solving a regular equation, let's pretend the x squared was just an x. What will be the first step to solve? Subtract 8 to both sides. That goes away. I get 5x squared is equal to negative 20. Now, still trying to get that x squared by itself before I can take a square root. What do I do next? Divide by 5. So, x squared is equal to negative 4. What's my last step? To get x by itself now. How do I get rid of the square? Take a square root to both sides. So x is equal to the square root of negative 4, or plus or minus the square root of negative 4. So whenever you're solving, you put plus or minus in front of it. Now, what is the square root of negative 4? Well, we already learned something. So first off, if I was to simplify that radical, what's the first thing I do? Take the I out. So x is equal to plus or minus I square root 4. Well, we know what the square root of 4 is, right? What is it? 2. So our answer is plus or minus 2i. So guys, when we're solving quadratics, no longer will I accept the words no solution. You're always going to have a solution, whether it be real or imaginary. All right. So since we know what imaginary is now, that's how we're going to play it. So let's try this one together. So again, treat it like you're trying to get the x squared by itself first. You cannot take a square root until that x squared is by itself. So what's my first step? Subtract the 20. So that's equal to negative 18. Now, 1/2 x squared. Who remembers how I get rid of a fraction when you're trying to solve an equation? You multiply by its, starts with an R.
Reciprocal.
Good. So what does it mean to multiply by the reciprocal? We're multiplying by what? What does reciprocal mean? Reciprocal just means you do what with the fraction? You flip it. So it would be multiplying by 2 over 1, which is just 2. So we're going to multiply both sides by 2. What's negative 18 times 2?
Negative 36.
Good. Now, since the x squared is by itself, take a square root. X is equal to plus or minus the square root of negative 36. Now, we need to simplify that radical. So what do we do first? We have a negative under the radical, so what do we do first? Take the I out. So x is equal to plus or minus I square root of 36. So we know what the square root of 36 is, right? What's the square root of 36? 6. So x is equal to plus or minus 6i. Try C on your own. So get the x squared by itself, take a square root, then simplify the radical. fair warning, this might not be a perfect square. Don't be thrown if you don't get a perfect square. You can't simplify square root of 21. It's not a square root. Thumbs up if you're ready. You guys, 1 more minute. But you did actually that. All right, let's go over this one. So, what is my first step? Jared. Subtract it or add it. My pen will work. There it goes. So I'm going to add the 10 to both sides. I get 2x squared is equal to negative 26. What's my next step, Olivia? Right, divide by 2 to both sides. So I get x squared is equal to negative 13. What's my next step, Rajan? Not square, but there you go. Square root. That goes away. I get x is equal to plus or minus the square root of negative 13. Now, what's my final step for simplifying? Taking a test. Carolina. Take the I out. That's all you got to do. So, with simplifying this radical, all you had to do was take the I out. That's all you could do. So your answer is x is equal to plus or minus I square root 13. We cannot simplify the square root of 13 any further because nothing divides into 13 besides 1. All right, 13 is a prime number, so we end it there. So good job. Walking around the room, most of you guys got that. So even if you can't simplify the radical, if it's negative under it, you have to at the very least take the I out. All right. Now, let's look at this next problem. So example 4 states, what is the equivalent to 5i times 6i? So first off, what's 5 times 6? 30. So that already eliminates this and this. So 5 times 6 is 30. So we handled that part. So that's what we're left with is I times I. What's another way that I can write I times I? Negative 1. Why is it negative 1? So why is I times I negative 1? I squared is equal to negative 1. We can rewrite I times I, because you're multiplying something by itself, as I squared, which based off of your definition on the previous page, I squared is equal to negative 1. So we're technically doing 30 times negative 1 which is negative 30. So if you multiply two i's together, it's no longer imaginary, it becomes a real number. Negative 30 is 100% a real number. All right. Now, the powers of I display a remarkable pattern that allows us to simplify larger powers of I. So there's one of four cases. Now, obviously, I, the first power, is just I. What did we just say I squared is? Negative 1. So I squared is negative 1. All right. Now, I cubed. So we know I squared is negative 1. So now we just got to multiply another I to it. So it's negative 1 times I. So what's a negative times anything? What's negative 1 times anything? It's negative version. So I cubed is negative I. So I cubed is negative I. Now, I to the fourth. Let's think about this logically. How many i's is in I to the fourth? 4. So we have I times I times I times I. How many pairs of 2's are there? There's 2. Right. So we have 2 pairs of I. And we know that we have 2 pairs of I squared. So we have I squared times I squared. Well, what do we know that I squared is? Negative 1. So if you have 2 i's, you have negative 1 times negative 1, which is what? 1. So I to the fourth is equal to 1. All of these that I just highlighted, I, negative 1, negative I, 1, that's always going to be your answer to any power of I. All right? So it'll be one of those 4 choices. So now, let's think about this logically. I the fifth, it follows 1. But we're so it's I the fourth plus another I. So I the fifth, we can rewrite as I the fourth times I. Well, what did we say I to the fourth is? It's what? 1. So what's 1 times I? I. So I to the fifth is just equal to I. I the sixth. I the sixth can be rewritten as I the fourth. So if I have I the fourth, how many i's do I have left over? 2 to make I the sixth. So I have I the fourth times I squared. So what is I the fourth? I the fourth. 1. What's I squared? Negative 1. So what's 1 times negative 1? Negative 1. I the seventh. How could I rewrite that using an I to the fourth? So I the seventh is I the fourth times, how many i's do I have left over? 3. So I cubed. What's I the fourth? 1. What's I cubed? Negative I. So what's 1 times negative I? Negative I. I the eighth. So if we start with I the fourth, how many do I have left over? 4. So we know I the fourth is both what? 1. So what's 1 times 1? 1. Now, do you guys notice the pattern that's going on here? So here's the answers that we got again. We got I, negative 1, negative I, 1. Didn't it follow the exact same pattern that we did previously? Right. All right. Now, here's the difference, okay? After the initial 4, it's all based off of multiples of 4, all right? So every exponent that's a multiple of 4, so if n is a multiple of 4, I the n is 1. Meaning, if you divide that number by 4, you get a nice number. So 16 is a multiple of 4, 8 is a multiple of 4, 32 is a multiple of 4, all right? And then I always say find the closest multiple of 4 that's lower than the current number. And then however many i's you have left over, that's your answer. Okay? So it's always I the first is I squared is -1, I cubed is I. So let's try some of these. First off, I the 38. Is 38 a multiple of 4? No. If you divide 38 by 4, you do not get a nice number. But there's a number near it that is a multiple of 4. What number is that? And I want the one that's lower than 38. 36. So I to the 36 is equal to I the 4th. So that's 1. So if I have I to the 36, how many do I have left over? 2. So I have I squared. So we know I the 4th is what? 1. So that means I the 36 is also 1. So any multiple of 4, so I raised to any power that's a multiple of 4 is always going to be 1. And then whatever's left over after you find that nearest multiple of 4, however many i's are left over, that's what you're multiplying to 1. So what's I squared? -1. Because 36 plus 2, that's 38. So what's 1 times -1? -1. So I the 38th is -1. All right. I the 21st. It's obviously not a multiple of 4, but what is the nearest multiple of 4 that's lower than it? 20. So I can rewrite this as I to the 20th times how many i's do I have left over? 1. So this would be 1, because 20 is a multiple of 4, times I the first is just what? I. So 1 times I is I. Are you guys seeing how this works? Kind of, sort of, maybe? Okay. Try C on your own. So find the nearest multiple of 4 that's lower than the current exponents. And then however many i's you have left over, that's actually your answer. So in other words, guys, the i's that you have left over, you should have less than 4 left over. I'll give you guys a hint. If you divide 83 by 4, the number that's before the decimal is actually the number that you're going to use. Yep. So that if you don't know what multiple you need to use, you divide 83 by 4, take the number that is in front of the decimal place, multiply it by 4. And that'll be the number that's the closest. Thumbs up if you're ready. All right, let's talk. So what I suggested is you divide 83 by 4 in your calculator. If you divide 83 by 4, what do you get? 20.75. So from there, you take the 20 and multiply by 4, and that is the multiple of 4 you're looking for. So what's 20 times 4? 80. So I'm writing this as I of 80, and then how many are left over? 3. So this is 1. What's I cubed? Negative I. So what's my answer? Negative I. So guys, if you can't find the multiple of 4, just divide the number by 4 initially. Whatever number is in front of the decimal, that's what you multiply back to 4. And that'll give you your multiple of 4 you're looking for, or the closest one. That's a little trick that you can use if you can't get it off the bat. Now, this last one. Without even doing any work, what do you think the answer to this one is? 1. Why?
Because 40 is going to be, because
40 is divisible by 4, meaning 40 is a multiple of 4. All right. So since 40 is a multiple of 4, not I, it would be 1. So if the exponent is a multiple of 4, it's just automatically 1. Any questions on that one? How to figure out what the equivalent of I raised to a power is? Okay, last one. So we're going to find the equivalent expression to this. So the first thing we want to do is we need to convert all of the powers of I into its simpler terms. So I to the 16th. What do you guys think I to the 16th is going to be? 1. Why? It's a multiple of 4. 16 is a multiple of 4. I the 23rd. What's the closest multiple of 4 to 23? Technically 24, but I want the lower one. 20. So always go lower with these guys. So I the 20 times, how many are left over? 3. So this would be 1 times I cubed, which what's I cubed? Negative I. So that's 1 times negative I, which is negative, I don't know why I wrote negative 1. So negative I. Last one, I the 26. So what is the closest multiple? 24. I know 28 is also the same distance. Remember, you want the smaller one. It should be smaller than the exponent. How many's left over? 2. All right. So I have 1 times what? What's I squared? Negative 1. So what's the answer? Negative 1. So I'm going to take these values and replace these values in the equation. So I have 5 times 1, which is I to the 16th, plus 3 times negative I, plus negative 1, which is I to the 26th. Now we're going to do some simplifying. What's 5 times 1? What's 3 times negative I? Negative 3I. And then minus 1. Now, combine like terms. What's the only thing I can combine? We can only combine the 5 and the negative 1. Why can we not combine the negative 3I with it? It has an I, which means it's not a what number? Real number. You can only combine real numbers with real numbers, imaginary numbers with imaginary numbers. All right? You can't combine them both together. So if I do 5 minus 1, what is that? 4. So my answer is 4 minus 3I. And we leave it like that. This is actually a true complex number. It's a combination of a real and an imaginary. So my answer is 2. Any questions on that? All right, so your homework for tonight is pages 9 and 10 of your packet. I will be checking it tomorrow. So you guys got a solid 20 minutes. Go ahead and get started. You can probably knock it out before the end of class. It's very similar to the ones that we did in class.